Okay children, now we are going to discuss a very small but very important topic, and that is decimal expansion without long division method. So in this topic we will discuss how to find when we have given a rational number in p by q form, okay, then how to find whether the decimal expansion of that rational number will be terminating or non-terminating. Clear? So we will discuss it how to find. Okay, let's suppose we have given any rational number that is in the form of p by q, where p and q both are integers, okay, and q should not be equal to 0. Okay, and one more important, in this case both p and q should be co-prime number. Okay, but a rational number where p and q are both are co-prime number. So okay, so after that what we will have to do, we will have to focus on q. We will have to find the prime factors of q, all prime factors of q. Okay, if all prime factors of q are in the form of, if prime factors of q are in the form of 2 to the power n something, it means 2 to the power something, or 5 to the power something, or 2 to the power something and 5 to the power something, it means the prime factor of q should be only 2 to the power something, only 2, no other number, only 5 to the power something, no other number, or 2 and 5 both are there. Okay, then only its decimal expansion will be terminating. Otherwise, apart from 2, if any other number is there, decimal expansion will be non-terminating. Apart from 2, any other number is also there, decimal expansion will be non-terminating. If so, let's suppose 2 is there, 5 is there, and apart from these two any other number is also there, in that case also decimal expansion will be non-terminating. So when it will be terminating, when the prime factor of q will be either 2 to the power something, or 5 to the power something, or 2 to the power and 5 to the power. Okay, so okay, let us try to understand this with the help of examples. Okay, so we have few examples. Our first example is 11 upon 16. So first we will have to check whether 11 and 16 both are co-prime numbers or not. So what do you mean by co-prime number? Two numbers are co-prime number if they have no common factor other than 1. Getting this or not? Only one will be common factor, other than 1 there should be no common factor. So 11 and 16, yes, both are co-prime number because only one is their common factor. Getting this or not? Okay, so now we will check without division. We are not going to divide it, but again we have without division, without long division, we have to find whether the decimal expansion of this rational number will be terminating or non-terminating. So what we are going to do, what I said, we have to focus on denominator, and we have to find the prime factor of denominator. So denominator is 16, so prime factor of 16, 2, 8, 2, 4, 2, 2 and 2, 1. So 16 can be written as 2 into 2 into 2 into 2, or 2 into 2 into 2 into 2, or we can say 2 to the power 4. So here what is happening, 11 upon 2 to the power 4. So this is in the form of, denominator is in the form of 2 to the power n. N means any number. N should not be negative. Okay, it can be 0 integer, it can be positive integer, but n should not be negative integer. Getting this or not? Apart from negative, it can be 0, it can be positive. Okay, so denominator is in the form of 2 to the power n. Yes, only 2 to the power n, no other number. Even there is no 5, no problem, but it is in the form of 2 to the power n, and apart from 2 to the power n there is no other number, so its decimal expansion will be terminating. If you will solve it, its decimal expansion will terminating. It means after a certain step we will find a fixed answer, or our remainder will be 0. Okay, as you dividing 11 by 16, your answer will be 0.6875. Getting this or not? Okay, another example. Okay, another example is 9 upon 32. Okay, so 9 and 32 both are co-prime number. Yes, both are co-prime number. Now without long division method, we have to find whether decimal expansion will be terminating or non-terminating. So for that, what we will have to do, we will have to find the prime factor of this denominator. So what is denominator here? 32. So you will find the prime factor of 32. So as I know, perhaps you also know, 32 can be written as 2 to the power 5. Only 2 to the power 5. No other number will be there. Okay, so here it will be 9 upon 2 to the power 5. So denominator is only 2 to the in the form of 2 to the power n. Getting this one, where n is any number except 0, except negative number. Okay, it may be 0, it may be positive integers, correct or not? So 2 to the power n in this form. So again denominator is in 2 to the power n. So as you will solve this rational number, or as you will solve this division, decimal expansion will be terminating. It means after certain step your remainder will be 0. Getting this or not? So you can solve it. I am not solving here because my main focus is how to find, without long division method, how to find whether decimal exponent will be terminating. And my focus is not to teach you how to divide any two numbers. Okay, so you will find its decimal expansion will be terminating. Okay, this is for you. Okay, again here, so 11 upon 125, whether both are co-prime number? Yes, both are co-prime number. They have no common factor other than 1. Okay, yes. So now we have to without dividing 11 by 125, we have to find whether decimal expansion will be terminating or non-terminating. For that, what we will do, we will find the prime factor of 125, denominator. So denominator is 125 and prime factor of 125 will be 5 into 5 into 5. So for you will solve it properly, but as I know, so directly I am writing. So 125 can be written as 5 to the power 3. Getting this or not? Okay, and denominator is in the form of 5 to the power m, where m is any number except negative number. It should not be negative integer. It can be 0, it can be positive. Okay, so again denominator is in the form of 5 to the power m, so its decimal expansion will be terminating. As you will solve this, so your after certain step your remainder will be 0. Getting this or not? So perhaps its answer will be 0.088. Getting this or not? Why I am not solving this? Because your answer will be after 4 or 5th decimal. Okay, so leave it. Again you pay attention. Now our next example is 13 upon 100. So first you have to find whether both are co-prime number. Yes, both are co-prime number. Okay, so numerator will be as it is. You have to find the prime factor of 100. So prime factor of 100 can be written as, okay, prime factor of 100 we will find 2, 50, again 2, 25, 5, 5, 5 and 1. So prime factor of hundreds are 2 into 2 into 5 into 5. So it can be written as 2 to the power 2 into 5 to the power 2. Okay, so decimal is in the form of 2 to the power n and 5 to the power m. Getting this or not? Yes, apart from these two, no other number. So 2 to the power m, 5 to the power n. It means in denominator there are the factor 2 to the power m and 5 to the power n. Apart from these two, no other factor is there. So decimal expansion will be terminating. Getting this or not? Clear? So if any other number would be there, so decimal expansion would be non-terminating. Clear, children? I hope this is clear for you. So as you will solve this, what will be your answer? It will be 0.13. Okay. Another example here, 11 upon 12. Whether both are co-prime numbers? Yes, both are co-prime number. 11 upon 12. Prime factor of 12. So 12 can be written as 4 into 3 and 4 can be written as 2 to the power 2 into 3. So now you pay attention here. So denominator is in the form of 2 to the power m. 2 to the power m or n, no problem. Okay. But apart from 2 to the power n, another number is also there, and this is not 5. If 2 to the power m, 5 is there, no problem. If 5 to the power m is there, no problem. If 2 to the power n, 5 to the power m is there, no problem. Okay, but if 2 to the power m and apart from 2 to the power m, any other number is there, any other factor is there, so its decimal expansion will be non-terminating. As you will try to solve it, it will go up to infinity. Decimal expansion will be non-terminating. You try to solve it and then tell me. Okay. Another example we have 13 upon 30. So whether both are co-prime? Yes, both are co-prime. So 13 upon 30. Clear? So 30, prime factor of 30. So 30 can be written as 10 into 3 and this 10 can be written as 2 into 5 into 3. So prime factor of 30 will be 2 into 3 into 5. Correct? Yes. So now you see the prime factor of denominator are 2 to the power n, 5 to the power n, and apart from these two, one more factor is also there, that is 3. So the decimal expansion of this rational number will be non-terminating. Again this will be non-terminating. What is the reason behind it? The reason behind it is the denominator, apart from 2 to the power m, there is another factor. Apart from 2 and 5, another factor. Here only 2 and 5, 2 to the power m, 5 to the power n, so decimal expansion terminating. 5 to the power m only, terminating. 2 to the power m only, terminating. 2 to the power m only, terminating. But apart from 2 and 5, if any other number will be there, it will be terminating. Now one more example we will try to learn here. Why I am saying every time that these two should be co-prime number. You may get confused. Where you will confuse, let's suppose we have another example, 12 upon 3. Getting this or not? So 12 upon 3, both are not co-prime number. Now what is happening here? In denominator, there is neither 2 to the power n nor 5 to the power m. Neither 2 and nor 5 are there, but still decimal expansion is terminating. Why this is happening? This is happening because these two are not co-prime number. Okay, if both would be co-prime number, definitely decimal expansion would be non-terminating. Another example we have 14 upon 7. So decimal, our denominator is neither in the form of 2 to the power n and 5 to the power m. Getting this or not? So but still decimal expansion is terminating. Answer will be 2. Why this is happening? Because these two numbers are not co-prime numbers. So this is the reason that every time I am saying that these two numbers should be co-prime number. I hope this will be clear for you.